everyone, and welcome back to another professional prep video. In this video, I'm just going to do a basic review of the important trigonometric functions. That includes our reciprocal functions as well as our regular functions. So starting out here, I have a right triangle. I'm going to call this angle theta. Let me get the pen option up. So this angle theta. We're given the legs, and I'm going to have us do some Pythagorean Theorem practice to get the hypotenuse in this case. It's really important to remember those fundamentals, Pythagorean Theorem being one of them. So this is a right triangle with legs of 4 and 5. So we can find this hypotenuse by using the Pythagorean Theorem, knowing that 4 squared plus 5 squared equals, and I'm going to call our hypotenuse C. 4 squared is 16, 5 squared is 25, and so with that we get that C squared is 41. I apologize for my handwriting. And that gives us C, and this is a side length, so obviously it's only the positive root, is going to equal to the square root of 41. Once again, I apologize for my handwriting. And so with that, we have our Pythagorean, we use the Pythagorean Theorem to set this up so that we can use trigonometry. So that's a nice start. I'm now going to say as the final step, in order to evaluate all 6 trigonometric functions. And so, let's get started with that. Let's start with what I hear the most as like the 2 most common functions that you're going to see a lot. And these 2 apply everywhere. They're very important. It's really important that you understand them, so please let us know if you have any questions at all. But first up, we have sine of theta. So sine, if you recall, SOHCAHTOA, sine is opposite over hypotenuse. Opposite to this, theta is 5, hypotenuse is square root 41. And you could rationalize this denominator, but for the sake of a trig video, I'm going to leave the answers in this form. And now we know sine of theta is 5 over root 41. I want you to consider which other trigonometric function, the reciprocal function of sine, has these 2 values and would then be root 41 over 5 and is equal to hypotenuse over opposite. If you said that function would be cosecant, denoted as C of theta, then you would be absolutely correct. Cosecant of theta is going to equal the square root of 41 over 5. And now we have those 2 reciprocal functions. That's interesting stuff. Let's move on to cosine. SOHCAHTOA. That the cosine is going to be adjacent over hypotenuse. Adjacent to theta is 4. The hypotenuse is the square root of 41. And that gives us 4 over root 41. Very similar to cosecant. What is the reciprocal function for cosine? If you said secant, or SEC theta, then you would be absolutely correct. And this brings us down to our final 2 functions here. And this is a reciprocal, meaning that it is simply the square root of 41 over 4. So we have the SO, we have the KA, now we need the TOA. TOA is tangent, and tangent equals, you might have guessed it, opposite over adjacent. Opposite is 5, adjacent is 4. So on this one we avoid the root 41s at all, and we get this value of 5 over 4. Tangent is the only, out of sine, cosine, and tangent, only those 3. Not looking at the reciprocals, tangent is the only one that has a range that can go above 1 and below -1. Just sine and cosine alone, with no multiplier out in front, cannot do that. Tangent can. So that's a bit of a self-check for sine and cosine. These 2 should not be above 1, and they sure aren't. Tangent can be, however, and sure enough, this is one example where it is. Now the inverse, so I started writing it here, is cotangent. For tangent, hopefully you knew that. If not, here's your little table summarizing each of these complete with an example. It's the reciprocal function, so it's going to be 4 over 5. Obviously, we can express those as decimals, but yes, there is your triangle, and here are your boxed solutions for the trig functions. So this is sort of a bit of a review, but also take notes of this, because take note of this, I should say, because this is going to come up again and again as we move further into trig, and it's going to be imperative that you remember these fundamentals. So yeah, here's your complete example with all 6 of these, and please do not hesitate to reach out if you have any questions at all. With that, I hope you enjoyed this video, enjoy the next one, and we will see you again soon. Please let us know if you have any questions, and I hope that you have a great day. Thank you.